in a division problem, it's all about the divisor. Now, what do I mean by that? If the divisor is negative, the solution to the inequality requires you to flip the inequality symbol. This is called an inequality symbol. The two lines, boop, boop, is called an equals symbol. Anyways, whether or not we worry about this at the moment, to solve, we multiply by -6, and you can put a 1 under it just to remind yourself that this fractional looking thing is getting multiplied by this fractional looking thing. Cross-canceling the -6's, which is reducing by dividing by their greatest common factor, is what we do here, leaving us with a 1 and a 1. X is what we're left with on the left, and -12 is what we're left with on the right. But since the symbol that or the number that we divided by, that's the divisor, since that number is a negative, your answer requires you to flip your symbol. It's no longer less than or equal to, it's greater than or equal to. And that's because the relationship numbers have with each other on a number line. I'll try to show you that. Going this way, as we go up, 1, 2, 3, we keep getting bigger, right? Am I right?
Yeah.
But in the other direction, despite being the same numerals, we get smaller. In other words, the further away from 0 we go this way, the smaller we are. In contrast, the further away from 0 we go this way, the bigger we are. That affects division and multiplication and inequalities. I can go further into that, but we don't have time. Just trust me when I say that if you are dividing, this is a division problem. X divided by -6 is less than or equal to 2. If you are dividing and the divisor is a negative number, flip that symbol.
So if it's not, I can keep it.
Correct. If this was a 6, regular old 6, you don't flip anything. It doesn't matter what this is. It's all about this. If this is a negative, flip the sign. If it's not, don't flip it. How did I get the 12? 2 times -6. Right? So we multiplied both sides by the -6. Right? Remember? So here's another example. B divided by 2, this is an old example, is 4. This is an equation. What number cut in half is 4? 8, right? If you didn't know that, the way you solve is multiply by the divisor, just like we did up here. Multiply by the divisor. This divisor is a 2. This is an old equation. The 2's cancel each other out. 2 divided by 2 is 1. So B is equal to 8. This is an example of an equation where we multiply to solve a division problem with a variable. Okay? Going back down the road of inequalities, I'm going to do a couple more with you. A divided by -4 is greater than 2. We will multiply to solve, just like we did above and up here and with all the other examples we've done. Multiply by the divisor. The divisor is -4. If you multiply the left side by something, you must multiply the right side by something. Notice I'm not writing the one underneath because it doesn't matter over here. It really doesn't matter over here either because you're visually, I just want you to visually recognize that this looks just like the multiplication of fractions that you've done in all your other classes. The result of this, the negative 4's on the left cancel out, leaving you with A. The symbol flips. Why does the symbol flip? Yes, Caleb. Negative 4, good. The answer is less than negative 8. To graph it, same like what we've been doing. Negative 8, negative 9. Anything less than but not equal to negative 8. So it's an open circle. Open circle. Less than.
Oh,
To test it, I'm going to test negative 12. That's down this way. And negative 12 is divisible evenly by negative 4, so that'll be easy for me to do. So I'm going to test this number. In place of A, I am going to put negative 12. I'm going to divide it by 4. And I'm testing it within the original inequality. Is the result greater than 2? Well, let's see. 12 negative divided by negative 4 is a what? A positive 3?
yeah.
Is 3 greater than negative 2?
Yes.
Good. We've tested it in the original equation. Now let's test it in the original inequality. Now let's test it in the answer piece where the sign has been flipped. Is negative 12 indeed less than negative 8?
Yes.
There you go. So I've tested it in 2 separate locations. Once in the original inequality and once in the final inequality where the sign has been flipped and it's still true in both. That's example 1. Okay? That's when you flip because the divisor is a negative. Here's example 2. Okay. Negative 5 multiplied by x is less than or equal to negative 15. Just like an equation, we would solve by dividing by the factor that we know. The factor that we know is a negative 5. The factor that we know is a negative 5. Divide by the one we know. And we're dividing by a negative. Dividing by a negative requires us to flip the inequality. Just like we did here. We flipped if the divisor is a negative, which we showed here. We're going to flip when the known, that's the negative 5, is the one we know, factor is negative. Is it negative? Yes. Which means x is greater than or equal to positive 3. Okay? Greater than or equal to positive 3. So that means, so anything bigger than 3, 3, 4, 5. Okay? Greater than or equal to positive 3. Okay. Let's test a 5. We're going to put it right here. Negative 5 multiplied by positive 5, is that less than or equal to negative 15?
Yes.
It sure is. Yep. Let's test it here where we've flipped it. Let's test that. Is 5 greater than or equal to 3? Isn't that funny how that works? So, and the reason for it is when you divide by or multiply by a negative number, the answer's sign is opposite. It flips. That is why the whole number line business makes sense.
Can we do it where it's
I'm not sure if I got it. If it's right in one spot, the number that you choose.
Then it must be an and equal to.
Yeah.
If this number is correct, then it's,
If you put it, will it always be the same if it's correct in one spot?
it should be correct in both spots. Yep. Yep, 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 yep.
question?
Yep.
Can we do one where it's the known factor or otherwise it won't be a negative?
Absolutely. So it's all about the known factor. If the known factor in this example 2, or if the divisor in example 1 are negative, you flip that less than, greater than, less than, equal to, you flip it, okay? But if they're not negative, like say something like this, 6x is less than 12, or x divided by 2 is 8. Notice, this is not a negative number. Divide by 6, divide by 6. X is less than 2. That's true. Or here, this is not a negative 2. It's a regular 2. X is less than or equal to 16. That would be true. When the divisor and known factor are not negative, do not flip. It has nothing to do with this piece. This piece does not matter. It's all about the known factor or the divisor. It has nothing to do with that piece. I'll show you here in a second. Take, for example, x divided by 3 is greater than negative 2. Is the 3 negative?
No.
Okay. Solve it by multiplying. X, negative 6. Do not flip the sign. Because why?
It's not the divisor or the known factor.
Then 3 is not negative. The divisor is not negative. Do not flip. Divisor,
Could be floppy not.
right, wasn't negative. Here's another one. Look with me. 4x is greater than 24. Negative 24. Divide by the 4. X, negative 6. Do we flip that? Why or why not?
Not negative.
Go ahead, Xander.
No, because it's not negative.
The 4 is not negative. Do not flip. Known factor. You know, 4 is a factor. X is a factor. 4 is the one we know. Known factor wasn't negative. So, that is your lesson in a nutshell.
Is that it?
We have one more thing we're going to do. You guys have a problem about geese. I believe on the first page there it talks about migratory geese, right?
Yeah.
Yeah, it's
Here's example 3. Geese can fly up to 18 hours, am I right?
Yeah.
16.
Is it 16? Oh, okay. 16, yeah.
Non-stop.
So flights must be less than or equal to 16 or less or greater than or equal to 16. Good. Up to
840.
16. Their distance can be as far as 848 miles. Good, yes. Justice, you're rocking this. Less than or equal to 848 miles. Okay, I'm just using F for flight, M for miles, just to kind of review what we discussed yesterday. That being said, their speed, what's their max speed going to be? So, if their flight is hours
So how many?
at a particular rate, we'll get them up to or equal to 848 miles.
Per hour?
Well, rate times time is distance, right? So we don't know the rate. We do know how long they can travel and their max distance. We know their max time and we know their max distance. By solving this inequality, Xander's waving at me, we can find their maximum rate. What is it, Xander?
This graph is 53 hours.
53, not hours,
53 miles per flight.
miles per hour. Can you even imagine? Can you even imagine? I know you guys know what 55 feels like, or 60 on a highway, right? Even like on Route 50 from Peatone to here, or Route 45 from Mantino to here. You know how fast you can drive. Imagine a bird flying almost that fast.